Hey guys, just going to do a couple of problems today, and I think they're two that we might have already done in class, but that's a good place to start. Make sure we're kind of getting our heads back in the game, trying to figure this out again, because we were talking about different types of neutralization reactions. We're talking about strong acid with a weak base, strong base with a weak acid, strong acid, strong base, which one there's more of. Remember, if there's more strong acid, if there's more strong base, whatever, there's different ways that we have to solve these problems. But remember, when we've got an excess of the weak thing with something strong, then you actually end up making a buffer solution. And so you can use Henderson-Hasselbalch and David Hasselhoff and save yourself some time. So the last thing we did was we looked at this, why strong acids and strong bases don't make buffer solutions. And it's because they completely dissociate, right? So, those are much easier problems. You don't have to use David Hasselhoff at all. So for this one, though, this is, we've got a weak acid, the acetic acid. We've got its conjugate base, that's its acetate, right? So, because remember, this is CH3COOH. This is just one way to write it. But that hydrogen right there, that's our acid. That's what makes it an acid. And this guy here, that's our acetate. So if I have sodium acetate, sodium doesn't matter, but I've got the acetate as my conjugate base. So conjugate base is that guy, and this whole thing, right? The whole thing together is our acid. And so in this case, what this problem's asking you for, you need a buffer of pH of 5. And how can you make it when you have, it doesn't say how much to make, but let's make a liter and that'll make it easy. I've got 0.15 molar acetic acid, and I've got some sodium acetate that I can add to it. So I can add conjugate base to the degree that I want to make it so that we get this pH buffer. So let's look at our David Hasselhoff equation. pH equals pKa plus the log of the concentration of the conjugate base and over the concentration of our acid. So we have this, well, we can calculate this, right? We have Ka, but we can calculate pKa, right? How do you, what's that little p mean? Do you remember? It's the negative log, right? The negative log of Ka is going to tell us is going to be equal to pK. That's what pKa means. So in this case, we can find that. We are given the pH. So we're given all these things that I've circled here, and we're just trying to find that. So we can rearrange this equation to get there. So it's going to be pH minus pKa equals, again, our log, the concentration of the conjugate base over the concentration of our acid. How do you undo the log? It's just going to be 10 to this. So we're going to do 10 to the pH minus the pKa equals our concentration of our conjugate base over the concentration of our acid. Now we have the concentration of the acid already. It's 0.15 molar acetic acid. So we're going to multiply that by both sides. So we're going to have our concentration of our hydrochloric acid, of our acetic acid, times 10 to the pH minus the pKa. That's going to equal our concentration of our conjugate base. Right? So I need a little more room to do this. From there, we've tidied that up. So let's put in some values here. Our concentration of our hydrochloric, or I keep saying hydrochloric because I keep saying that H. Our acetic acid is 0.15 molar times 10 raised to the pH, which is 5.0, minus our pKa, which we can find that it's going to be the negative log of 1.8 times 10 to the negative fifth. And that's going to be pKa. And so that equals 4.7447, blah, blah, blah. That's at plenty. We'll round off anything else. Actually, we'll round off that and more. 4.7447, we'll put that there like that. So we punch this in all into the calculator, and you're going to get, so this is going to be 10 to the, well, I'll go ahead and keep going step by step since I have that done already. To the 0.2553 roughly So that makes it 0.15 times 1.800-ish, which gives us about 0.27 moles, or molar, right? 0.27 molar. Let me erase that. So if I want to make a liter of this, right? So how can you make this with sodium acetate and this 0.15 molar acetic acid? I could take a liter of the 0.15 molar acetic acid and just add 0.27 moles to it, and that would get me there. Now, technically, I should probably have to be able to turn that into grams. That's stoichiometry. I don't think you need to worry about that too much. If you're curious, if you did do it that way, it should work out to be 22 grams. You should add 22 grams to a liter of this 0.15 molar acetic acid, and that would be the final answer. This is not a greatly worded question. Looking at number 25. Pause the video now, solve it, see if you got it right. If you're doing something wrong and you don't know what to do, right, let the video play until you get a hang of it, then pause it as soon as you can and try and do the rest from there, right? That's the way you want to do all these. We're going to be doing a lot of problems over the next few weeks, and this is the way we're going to be doing it. You need to solve them yourself. If you just sit here and watch me do this, that's not going to do anybody any good. So make sure you're solving these problems. Check your answers with your neighbors, right? Call a friend. We'll do these together. Like I said before, I think it's worth, Skyping or something while you go through the video. Do that together. And pause, get your answer, check your answer with your neighbor, and then you can double the speed and go right through me explaining it, or even just click ahead, whatever, who cares. I'm not saying anything too useful if you already know how to solve these. But this one is very much the same thing, only this time I actually ask you how many grams, so we're going to have to get all the way there. I did say 1 liter, so that makes it easier. But this is basically the same problem we just did. And so I'll just rearrange this equation again. Concentration of our, this is formic acid. So like this. So again, we're trying to solve for that conjugate base. We want to know how much, because our conjugate base is this guy right here, this formate. And so formic acid is just this. It's that guy right there with that acid instead of the sodium. So we have 0.2 molar, that should have M there, and it doesn't, but 0.12 molar of this guy. And then when I add the sodium formate, right, I'm adding the conjugate base of that acid. So we want to know how much of that we have to add to a liter. So we need it in moles. Well, actually it says how many grams, so we'll have to do that conversion as well. But rearranging this equation, we will get that the concentration, and this is just like the last problem, of the conjugate base is equal to the concentration of the acid times 10 to the pH minus the pKa. And there's my Ka, so I could find the negative log of 1.8 times 10 to the negative fourth. And that's going to be, let me write this pKa just so it makes sense. And that equals 3.7447. That seems familiar. So pH minus pKa is what was that? That's where's our pH? Our pH is 3.8. So 3.8 minus 3.744 equals 0.05527 roughly. That'll give us plenty of figures, but that's not a 7, that's a 2. So there we go. That'll give us plenty of sig figs for us. 10 raised to that, 10 to the pH minus pKa equals what do I get there? 1.1357-ish. And then we're going to multiply that times our concentration, which is 0.12. So 0.12 times, well, basically what this is going to equal is 0.12 times 1.1357. And that gets us our answer, which is 0.1362 molar. We can turn that is equal to moles because we said 1 liter, right? So if this is moles per liter, how many moles in a liter? Well, there's only 1 liter, no problem. So I need 0.1362 moles of this format of this sodium formate, this guy right here, right? And I want to get rid of that moles. So we need to calculate how many grams there are in 1 mole of this guy. And so what that's going to be, well, you can even look it up, but it's just going to be a sodium plus a carbon plus a hydrogen plus 2 oxygens. And that's going to get you, what, 68.1 grams per mole. So 0.1362 moles times 68.1, that makes the moles cancel out. Now we've got how many grams we need. And when we get it to sig figs, I think we've only got 2, so 9.3, 9.28, but 9.3 grams. So that answers our question of how many grams. That's our final answer. We're all done with that one. Okay, so that's 24, that's 25. Like I said, I think we might have done those before. If we did, that's fine. It's a good reminder. If we didn't, well, now we have. Tomorrow we'll do 26, 27, and I think probably 28 as well. Probably do 2 or 3 problems over the next few days. These, the last 6 problems are going to be different types of neutralization reactions where we have strong acid, weak base, etc. All the different possible combinations. You have to be able to recognize which type it is and then solve it appropriately. I hope that isn't too painful. Hope everything's going well with you guys. I've trying to make this work as well as possible. I wore the right shirt today. I think that helped, my glasses and everything. I went to the grocery earlier today and I had I took a Lysol, I had a canister of Lysol wipes in my car and I took one in with me. And I found myself every time I touched a refrigerator door at the grocery, I would wipe my hands with it. And I found after a while that I was just holding it like a little whoopee, for comfort. It was, I don't know. This is still weird. It's weird that I need a security blanket for going to the grocery. But anyway, hope you guys are doing well. Miss you guys, and we'll see you tomorrow.